We're going to be looking at one of our screw cutting jobs. By now we would have done a little bit of theory on screw cutting, and we need to look at the job that we need to do to reinforce those skills. We're going to be cutting 4 different threads, and we're going to be using a different tracking mechanism, or method I should say, for each process. And the first thread we're going to look at today is the imperial thread. Now we're going to cut this imperial thread on a metric machine. So we'll be using the reversing the machine method for thread tracking. We'll worry about the other tracking mechanisms in the next lesson. So we might have a close-up look at the job now. So here's our job here. We've previously machined this blank up a couple of weeks ago, and we've got 4 different thread diameters there machined up and ready to go. In between each thread we've got a necking groove, and that'll help us stop the tool or terminate the tool. And you'll notice that the first one up here is a 1-inch UNC by 8 TPI. That's the one we're going to do today. The other 3 threads here are metric, and we're going to use, one's left-handed, we're going to use different methods of thread tracking on those and different methods of measuring. Notice we've got 2 attempts, so if you have a go at the first one and you make a mess of it, we'll machine it down and go to the second size. So being we'll go back to this thread here, being an imperial thread, 1-inch UNC, the thread angle is going to be the same as these metric threads. It's 60 degrees, so we can use the same tool. But it's 1-inch TPI. We can't get that on this lathe. This is a metric lathe, so we're going to use the reversing the machine method. So now we're familiar with this drawing, what we might do is go over and have a closer look at the tool post and the tools I've got set up over there, and talk about how we grind them. Okay, so these are the 2 tools I'm going to be using during the thread cutting lesson. Now today we're going to be using high-speed steel. I'll get back to that in a minute. One of your other metric threads, we're going to use a carbide insert, and we're going to use the plunging type in-feed method for that one. But I'll talk more about him down the track. Today what I want to talk about is the high-speed steel method, because that one there we can grind. If we've got a piece of high-speed steel, we can grind it to any thread angle and do any job we need to. We don't have to rely on a particular insert for that particular job. So we need to know how to grind that tool and set him up. So what we might do is we might come over, have a closer look at this tool now, and I'll talk to you a bit more about him. So here's my high-speed steel tool here. It's a piece of 5/16 high-speed steel, and you'll notice it's got that V-form thread on the end there. Now the way we get that, we've got to grind him up on the offhand grinder. Now that angle there obviously is going to be different for different threads, and today, there being a metric thread, we've got a 60-degree thread. So I'm going to use this tool angle gauge to just double check that thread. I'm assuming that by now we will have ground this up. So if I bring this tool over here, being 60 degrees in these grooves, I should be able to line that up with my tool, and it should be pretty close to 60. And that one is there. It's probably not perfect, but it's 99% thread angle. So not only do we need the correct angle on the front of the tool, we also need some side clearance. We want about 6 degrees there. And we also need a nose radius. Now the nose radius differs with the different type of thread. It's based on the pitch of the thread. We have a formula for working that out. It's 0.125 times the pitch, but you're not going to remember that in a workshop. So an easy way to remember, let's say I was cutting a 3mm pitch, I'll use a 1 or 1.5mm pitch thread pitch gauge, and I'll get my thread pitch gauge, I'll set that to 1.5mm, and I'll check it. This thread pitch gauge here is set to 8 TPI, because we're not cutting a metric thread today, we're cutting an imperial thread. So even though it's 60 degrees for the imperial UNC, we want a thread pitch gauge set to 8 TPI. And I'll talk about why we need that in a minute. What we might do now, we might get that, now that we've got that done, we might move over to the lathe headstock, and we'll look at what levers we need to change on the lathe. So we come over here to the headstock. We need to set the lathe to 8 TPI. That's 8 threads per inch. Now we've got that on this lathe here. In these 2 boxes here, we've got metric leads and we've got imperial leads. We can also cut worms, and we've got feed here on this side of the chart. Now we're going to be looking at this chart here today. It says 1 inch, or inches I should say, and that means that all these leads that we get here have got to be in the W range. So we've got W set here on this lever. Now what I need to do is simply look down the chart and find 8. There's 8 there, 8 TPI. So I've got to have the rest of the levers in LB1T. So if I come up here, I've got the lever LB1T. So that should all be right to go. You'll need to calculate that beforehand, and we'll talk about how you do that in a minute. The next thing, I come up to the speed up the top here. I've got the speed in this case here set to 80 revs, because when we cut with high speed steel we want about a quarter of the speed we would normally, and so that's worked out about 90, but I haven't got 90 in this machine, so I'll set it at 80. So we've now got the headstock set for the right threads per inch. We've got the speed set. The next thing we need to do, we need to go and have a look at our tool setup, but what we might do before we get there is we might look at some of the calculations we need to machine this thread. So now I've got this little sheet up here for you to look at. We will have done something similar to this in class. There's only 3 different sort of calculations there that I've worked out. In your job plan sheet you will have done in class, there's quite a few more. But this is the bare information that we need for this exercise. Exercise 1 is a 1 inch UNC 8 TPI thread. We're going to use high speed steel, and it's a right-handed thread. So one of the things we need to do is turn the material to size. Now we've already done that. When we're turning these threads, the blanks to size I should say, we're going to turn them about 02, 05 undersize, because as we machine the thread they tend to grow and we want allow a little bit of room for clearance. But what we do need to know is the depth, how deep to go. Now when I look at the thread itself, I need to plunge in one side. When I plunge in one side, that gives me this measurement here, but we all know that these lathes nowadays, they take this material off the diameter rather than the radius. So what I need to do, because this measurement here, 2.03 millimeters, is just from the crest of the thread to the root, I've got to allow that for both sides. So to work out the minor diameter, I've got another formula here. The minor diameter of this thread is the major diameter minus 2 of this formula here, which is the depth. You'll notice you compare the 2 at the top. If I get the major diameter and I take 2 of these away from the major diameter, I end up with this, 22.79. So that's my minor diameter of this thread. It's a 1 inch to start with. 1 inch is 25.4. We know we've got to go down now to 22.79. Okay, and here's my speed formula here, 300 V over D. So 300 times 30, 30 is a cutting speed or velocity for high speed steel. And we're going to run that about a quarter of the normal pace, and we'll put it over the diameter of our job, and this being a 1 inch thread, it's 25.4. You'll notice I'm converting all these things into metric. We're using a metric lathe, so it's just easier to convert the threads per inch and the diameter into metric. So now we've got the blank machine, we know what the minor diameter is, so we know how deep to go. What we might do is go and set up our tool and get screw cutting. Righto, we're back over here with the job now, and you'll notice I've got the tool, the high-speed steel tool, in a holder and in the cassette and the tool post. There's a couple of things we need to do to set up this tool. First of all, we've got to get him on centre height. So I know there's a few different methods of getting a tool on centre height, but I like to use the rule method. I've always got a rule in my pocket, so I carefully bring the tool in against that rule and hold him there. And if I look down from this angle here, I can see that I've already set this bloke up on centre height. So we've got to do that, and the next thing we need to do to set the tool up is to make sure the tool angle is square with the job. And that's what we need the tool angle gauge for once again. And what I do is I simply get my tool angle gauge and I sit him on the front of my job, on front of my tool rather, hold him in there nice and square, and I bring him up against my job. Alright, and you may or may not be able to see there, but at the moment there I've got more gap on this side than I have on the other, so that tool isn't square to the job at the moment. So what I'm going to have to do is get the spanner for the tool post and make an adjustment. So I'll just set him up there again, and I'm going to adjust the tool post around a little bit, wind him in until I get that just right. Hopefully. There you go, that's pretty good there. Now I'm going to nip him up, nip the tool post up. Now I've got the tool on centre height, I've got the tool square to the axis of the job, I'm pretty well up to the screw cutting stage. Now one of the first steps we need to do is obviously we'll bring our tool down here and we'll zero our tool on the job. So I'm going to just do that now. When I'm zeroing the tool, I like to do it with the machine turning, and so I'm just going to start the machine up and zero the tool. That way I don't damage the tool. Right, that's pretty close to zero there. I'm going to zero the dial now, so I know where I'm at, and I'll bring my tool back to the beginning. Alright, and I'm just about ready to start. So I've put the marking blue on here so we can see a bit more clearly what's happening. I'm going to take a trial cut first, and the idea of the trial cut or the test cut is to see if I've got the headstock gears in the right position. I don't want to go ahead and turn that screw thread, take a big cut of like half a mil and find that the levers are in the wrong spot and I've made a mess of the thread. So if I take a trial cut, I can work it. I'm rest assured that doesn't happen. Now what I need to do now is I've got to engage the clasp nut on the carriage to the lead screw on the lathe. Now there's a lever on the front of the lathe around here. The one right at the bottom is for the feed, but the one to my left just here, the one you haven't used yet, is to engage the clasp nut. Now for this particular job, because it's imperial, we can't use this thread dial over here and this lever to engage and disengage all the time, because the clasp nut won't align with the lead screw properly. So what we need to do in this case, being imperial, we'll engage that lever and we'll leave him engaged now for the rest of the screw cutting process until it's finished. We won't disengage that, and what we will do is simply reverse the machine electrically to bring the tool back. So the first thing I'm going to do now is I'm going to wind on a small cut. I'm going to wind on about 0.1, and I'm going to take a trial cut along there, and I'm going to stop the tool in the necking groove here, and then we'll measure it. So I'll just do that. Now when I've stopped the cut there, I've left that lever engaged. I've simply brought the machine into neutral and used the foot brake to stop the tool in the necking groove. Now I'm going to use my screw pitch gauge. I've got him set to 8 TPI, and I'm going to just line him up with those grooves and see if I'm accurate. And luckily, in this case here, I've set the levers in the right spot. It's okay. So I'm pretty happy now. I can go ahead and take some more cuts. Right. When I go back to my sheet, I think we had a minor diameter of 22. What we'll do now is we'll take a couple more cuts. What we've got to do with this process, we're using the side cutting process. So what I'm going to do actually now, I'm going to move back and get ready for cut number 2. Wind this back out because I don't want to track back over the original thread. I'm going to raise this lever up and reverse the machine back to the original position. And stop. Alright, I'll bring that back into 0. I think I did 0.1 last time, so I'm going to go there. Now the first cut, I want to rough this out now. We take roughing cuts and finishing cuts just as you would on any other job in this process. So the first cut I'm going to do is I'm going to actually take on about half a mil. Alright, and I'm going to use a bit of this cutting compound. You can use coolant, but I like to use cutting compound because I tend to get a better finish with it. So I'm going to wind on half a mil there. I'll go to about 0.6, and I'm going to take this first cut. Let's see what happens. Alright, so we've taken the first cut. That's no dramas. I'm up to 0.6. I'm going to wind that back out to 0, reverse the machine. Now what I've got to do, I've got to take consecutive cuts now until I get down to the right depth. Now because it's a side cutting method, I went 0.6 before, I'm going to go another ½ mil again, so that's 1.1. I'm going to wind him on there. But this time, instead of just winding the cross slide on, I'm going to wind the compound slide as well. Because if I just take this cut now, we're going to be cutting on both these edges of the tool. We're going to cut on this side and that side. Now what that does is that puts a lot of load on the point of the tool, and what happens, we tend to get a bit of a torn rear flank. So the side cutting method, the idea is that it cuts on this front flank all the time. Alright, and the way we do that is when we wind a cut on with the compound slide, or the cross slide I should say, we also wind the compound slide a little bit. So as we're always cutting on this front flank of the cutting tool. Now what we do, I've just wound this on a ½ mil here on the cross slide. What I now need to do is also wind the compound slide. I'm going to wind the compound slide a quarter of the amount that I've wound the cross slide. So because I've wound on the cross slide ½ mil, I'm going to go, what is it, about 0.15 or something like that here on the compound slide. Now I've got to make sure that there's no backlash in there. I've got to wind the backlash out of the compound slide. I'm just going to 0 him. Alright, and I'll wind him on a little bit. Okay, I might go 0.1. Alright, close enough, and that'll just ensure that we're cutting on this front flank. So I'm going to take cut number 2 now, and then we'll do some more off the camera, and then we'll show you how to finish the thread. Alright, so what's happened there now, we've stopped in the necking groove again. I've used the brake this time because we haven't got a lot of room. It's cut on the front flank. Now what you need to do is retract that tool, come back to the beginning and keep taking some more cuts, ½ mil cuts will do you. And don't forget, you need to increment the compound slide a quarter of the amount you use or you wind on the cross slide. Do that until you're about 0.1, 0.2, almost down to the minor diameter, and I'll show you how to do the finishing of the thread when we get there. Righto, I'm back here now. I've taken a few more cuts. I've roughed it out. It's now down to depth according to my calculations. Everything's still engaged here, but as you can see from the appearances, the thread looks a bit ratty at the moment. Now during that roughing process, what happens is the tool gets a bit blunt, so probably before you start the finishing process now, you should probably take this tool out and give him a little hone on each flank with an oil stone, and that'll just sharpen that edge up. You should get a better finish. You can see there's a little bit of tearing on the flanks of the thread. Now the idea of this is to do the finishing part of it is to clean up those flanks and widen the thread out so as the root of the thread, the gap in the root of the thread looks the same width as the flat on the crest of the thread. We've got to have an even thread. Now at the moment you can see in the bottom there it's very narrow, and the crest of the thread is a lot wider. So we need to even that up. And the beauty of finishing is that it gives us a better finish, but it also allows us to marry up those threads so that they look the same. So I'm assuming that I've just sharpened up my tool. I'm at the same depth here on the cross slide. I'm not going to actually adjust the cross slide now in terms of going deeper. What I'm going to do now is take a few cuts, and I'm going to take them on this flank, on the forward flank, and then on the reverse flank. But only very small cuts. So I like to use a little bit of this cutting compound on there, especially during this process. So I'm going to start him up now. I'm going to take the same depth of cut. See what happens? So at the moment it's still taking a bit of a cut there, but nowhere near as much as it was before. You stop him in the groove there. Alright, now it's a bit hard to see, but I'm looking at from this angle here, and the thread itself doesn't look too bad. I'm just going to reverse him back out now. and go back. Now I'm going to wind back in. I'm winding this one back into 4mm. That's where I was before. Right, I don't think I'm going to wind this cross slide or compound slide at all at the moment. I'm just going to take another cut. I'll take I guess what you might call a spring cut. Alright, and you can see, look at that spring cut. It's still taking a little bit of metal off there. And that's good because that small cut means it's going to be improving the surface finish. I'm happy with the surface finish on this flank at the moment. Now what I need to do, I'll reverse and I'm going to take a cut on the second flank, on the back flank. So I'll wind my tool back out and reverse the machine. Alright, I wind this back into 4 again, because remember I'm already down to depth. I just want to clean up the flanks. Now I've been winding the compound slide forward all this time. I want to cut on the back flank this time, so I want to wind this compound slide back. Notice I'm winding the backlash out. I wind the backlash out and then I'm going to bring him back about 0.1. I'm going to see what happens. Alright, you can see the tool now, it's sort of cutting on the back flank. Now that's good because that gives us an opportunity to clean up that back flank, but it also will change the profile. You can see this at the moment, if you look here, it's nice and clean. The crest of the thread's still very wide compared to the root. So I'm going to now take a few more cuts on this back flank. I'm going to increment the compound slide a little bit every time until I get that looking even, and then I'm nearly up to the measuring step. So let's assume that I've taken those cuts and those flanks are looking pretty even at the moment. What I'll do is what might happen is it might throw up a bit of a burr on the crest of that thread. I might touch it with a file at low speed just to knock that burr off. Then I'll measure it, make sure my root diameter and my outside diameter are right. And then in this case here I'm going to try the test nut on it. If I can't get the test nut on there, it means I've obviously got to take a bit more material off it. If you can start the test nut and it doesn't go on, there's nothing stopping you putting a bit of marking glue on there, wind the test nut on and see where it's rubbing, because obviously where it's rubbing it'll rub the blue off. Alright, so the finishing process is just as critical if not more critical than the roughing out. So we want three things we're looking for. We want a good fit and we want a good form. In other words, the thread needs to look even, and we want a good finish. So fit, form and finish, and you'll be passed. That's enough for me now. Probably next time we'll look at the half included angle method and the plunge method of thread cutting.